Alright everybody, welcome back. In this video we're going to talk about how we make predictions from trends that we see in displayed data. Specifically, we're going to be looking at making predictions usually from things like line graphs and bar graphs. And what we want to do when we look at these is we want to analyze the trends that exist in those graphs and use those trends to predict what's going to happen for future values further along down the line. There's a little list here of 4 things that you should consider when you're looking at this. First of all, when you're looking at the bar graph or the line graph, are the values increasing or decreasing as we move from left to right? This tells us whether we should expect our future values to be larger or smaller than the values that we see in the graph that we're looking at. Is there a pattern in how the values increase or decrease? Are they increasing by roughly the same amount, indicating, a linear trend rate? Or are they doubling, or are they decreasing by the same amount? What kind of pattern exists in what's going on with our trend? And then once we've figured out what kind of pattern exists, especially if it's a linear type trend, we want to look at, how much do the values increase every 1 unit we move to the right, 2 units, 3 units? What kind of trend do we see? And the last thing we need to consider is how much further out on the graph we need to go to make our prediction. Sometimes it's helpful for us to actually visually extend the graph. Sometimes that's not as helpful. So let's go ahead and we'll look at a couple of examples of using this concept to answer some questions. Here we go. Alright, and we'll start with this bar graph. The number of students who tried out for the CCHS Quiz Bowl team in the years 2014 to 2018 are shown in the bar graph below. How many students would you expect to try out for the team in 2020, and how many students would you expect to try out for the team in 2025? Alright, so first thing we're doing is looking at the trend in the data, and you can see from these bars that we have, an increase from 2014 to 2015, then a little drop back to 2016, then another increase in 2017, and another increase in 2018. If you look at these bars, with the exception of 2016, it looks like we're really close to a linear growth rate throughout that time period. And so what we're going to do is we're going to try and figure out, how much that increase is by estimating where these bars fit on the graph and going from there to try to predict what's going on in the future. This first bar looks like it's at about, let's call that, it's either 16 or 17. We'll call that 17. Then the next year it looks like it's at about 25. And then the next year it looks like it drops down to about 23. And then the next year it looks like it grows to, about 35. Yeah, about 35. And then in that last year it grows to maybe a little bit more than 40. Let's call it 41. But if we look at what's going on with this growth, over the time period from 2014 to 2018, there's been an increase of 24 people over those 4 years. So our growth here looks like about 6 people per year. And so to make our predictions, I'm going to utilize that rate, about 6 people per year in growth. And now we're going to look at 2020. So 2020 is 2 years beyond what we have on our graph. So if we go from this number right here in 2018, and we add about 6 people a year, we're just going to add 6 to this 41. We're going to add that twice, or 12. And so 41 plus 12, I'm going to predict that about 53 people are going to try out for this team. Now, is this an exact science? No. I mean, our prediction here could have been probably anywhere from 50 to maybe 55. And in context, when you're trying to answer questions like this, a lot of times you'll be looking at a multiple choice type question where, there will be one answer that sticks out as being in the possible predictive range. All right, let's look at part B. How many students would we expect to try out in 2025? Well, another 5 years will have elapsed. If we gain another 6 people per year over those 5 years, so I'm going to take 6 times 5, and that's 30. So we're going to expect 30 more people than we had in part A here. So let's say that we're going to predict about 83 tryout. All right. Now, one of the issues with making predictions from trends is the further away we go from our data, 2025 was 7 years into the future versus 2020 being 2 years into the future. The further out we go from on our data, the more likely it is that our model will predict, wrong. We'll probably over-predict what's going on because it's hard for these trends to continue for long stretches of time. But that's not something we're going to worry about too much. All right, let's take another look at another example here. We're looking at a line graph here. The line graph below shows how Miguel's hourly rate of pay changed during the last 5 years. What would you expect Miguel's hourly pay rate to be in year 7? And when we look at this, we can see that, again, the trend in the data is very close to linear in fashion. If I draw a line from the first point to the last point, that's very close to linear. And so we can expect that his hourly pay rate is going to move up at roughly this linear rate. Now we need to figure out what this linear rate is. Well, he started out at $8.50 in year 0 and ends up at $12.50 in year 5. So what I'm going to do is I'm going to just find the slope of this, line that I put over top this line graph, and I'm going to use that to help me predict $12.50 minus $8.50 over 5 years. And we expect his hourly rate to go up on average about 80 cents per year. So if we want to guesstimate or predict year 7, we want to go from where we are at year 5, and we're going to add 80 cents a year. We're going to add that twice. So that gets him up to about $12.50 plus 2 times 80 cents, about $14.10. So instead of going to the nearest 10 cents, I'm just going to predict that it's going to be about $14 in year 7. All right. Now the next thing it asks is, in what year would you expect Miguel's hourly pay rate to hit $18? Well, we think from here that it's going up on average about 80 cents a year. So let's keep adding 80 cents to that $14. And in order to do that, we need to add it 5 more times. So 5 more years than part A. Because, we're taking 14 plus 5 times that 80 cents. That gives us $18. So 5 more years beyond that in part A. And in part A, we were in year 7. So 5 years after year 7 is year 12. So we're going to say around year 12 that he should expect his hourly pay rate to hit $18 based on the trends. So, to wrap up here, when we're using and making predictions from trends, realize that it's not like this is an exact, perfect science. We're taking the information that we have, and we're trying to get close enough to where we think things are going to occur. And a lot of times we're going to use that concept of the average rate of change over an interval to help us make predictions further down the line. And while there are a lot of other different kinds of things that we can see in predicting, from our line graphs and bar graphs, this is the most basic and will help us the majority of the time. Other times you might see bars or lines that increase in a fashion that is certainly not linear, like maybe it increases by more and more each year. And if you see something like that, then you need to take that into consideration. Instead of using a linear model like this one, then, look at how much it's increasing from year to year and see how much the increase is increasing, and use that to help you make predictions further down the line. Anyway, that's it for this video. See you guys next time. Have a great rest of your day.